Hello everyone, welcome to the chemistry channel. So today we are gonna be talking about the different types of processes that occur in thermochemistry. So in this video we're going to be using a lot of what we learned for the first law of thermodynamics. So if you are not acquainted with this equation, I encourage you to see the previous video and then come back. So the first process that we're going to be talking about is the isobaric process. So please note a little warning here. The types of processes, general chemistry classes will generally want you to memorize the equations associated with each process. However, I just don't want to give you the equations without any context. So what I'm going to be doing is doing the derivations in order to get there. They're not that hard of derivations to do, but please note that you don't have to know these derivations for your general chemistry class, generally. So this is just to give you a little background context to see where they come from. So what is an isobaric process? An isobaric process is a process that occurs at a constant pressure. So iso means same, baric refers to pressure. So what is the equation associated with this process? Well, we're going to start off with our first law, du is equal to dq plus dw. So now we're going to plug in all of our terms. We know that dw is equal to negative p external dv. Therefore, du is equal to dq minus p external dv. And if you're at all confused about this equation, go to one of my earlier videos where I explain it. And I think it's labeled heat, energy, temperature, work. So we're going to assume a reversible system is equal to dq minus p dv. And we're going to assume constant pressure, because that's what an isobaric process is. So therefore, when we integrate everything, we can keep it the pressure variable outside of the integral. So we're going to integrate everything. So our upper and lower bounds here. And when you integrate this, you get delta U is equal to Q minus P change in V. And you may recognize this equation from the last video. So this is the constant pressure equation. So this is a very common equation to use. The second type is an isochoric process. So an isochoric process is a process that occurs at a constant volume. In other words, the volume does not change. So this means change. So what is the equation for this one? So we're going to start off with our first law again. And we're going to assume a reversible process. So we don't have to write what we just wrote in the other one. Now, in this case, this should be rather easy. The volume does not change, so this means that dV is equal to 0. So this whole term gets eliminated. So therefore, du is equal to dq. And when we integrate this, we get change in u is equal to q. So in other words, for an isochoric process or isovolumetric, the change in internal energy only depends on the heat gained or lost by the system. So if the system loses heat, the internal energy decreases and delta U is negative. If the system gains heat, Q is positive, therefore delta U is positive and the internal energy increases. So the next process is called an isothermal process. So isothermal. So what is an isothermal process? Well, an isothermal process is a process that occurs at constant temperature. So it occurs at constant temperature. So we're going to write our first law again. So do you remember what the definition was for temperature? The definition of temperature is the average kinetic energy of the system. So if our average kinetic energy of the system doesn't increase, then du must be 0. There's no change in internal energy. Therefore, dq will be equal to negative dw. So when we integrate this, we get Q is equal to negative W. And this is for an isothermal process. And then the last process is the adiabatic process. And this is a process in which the system does not gain or lose heat from or to surroundings. So in other words, what would the equation be for this? So we start off once again with our first law. And if no heat is gained or lost from the system, Q, dQ, will be 0. Therefore, du is equal to dw. And when you integrate this, you get change in U is equal to W. So the change in internal energy depends on the work done on or by the system. And remember, if work is done on the system, W is positive and du will be positive. And if work is done by the system, W is negative and delta U will be negative as well. And that is it for all the processes. So the 4 equations that I box in are the ones that you need to know. You probably do not need to know the derivations. However, they do help in order to understand where they come from. So I thank you all for watching, and in the next video, we're going to define what enthalpy is. So I hope to see you there.